Bismillahirrahmanirrahim. I am your statistics teacher, Professor Dr. Afaq Ahmad. Today we will start second part of your syllabus, that is probability. Before probability, I will explain some important definition. We will use these definition in probability. The first definition is sample space. The definition of sample space is the set of all possible outcomes. Set of all possible outcomes of a statistical experiment. Each word is very important. Set. You have used this term in mathematics. Set. Possible outcomes means all possible results of any experiment, any procedure or statistical experiment is called the sample space, and is represented by the symbol S. You have used the symbol S for standard deviation also. This is a capital S. Each outcome in a sample space. Each outcome in a sample space. You will obtain the outcome from experiment. Each outcome in a sample space is called an element or a member of the sample space. With the help of this example, you can understand this is very simple example and most popular example used in probability and all possible arrangement. You have already used this example in mathematics. So when a coin is tossed or thrown, possible sample space are, possible results are H, maybe T, maybe H or maybe T. The total outcomes, possible outcomes is called sample space. So all possible outcomes, if you throw a coin, this is the experiment. You can throw a coin 1 time, 2 times, 3 times, etc. This is called experiment, statistical experiment. Why this is statistical experiment? You know that with the help in the statistics we interpret the data, observations, values, statistics. So with the help of this experiment, if you throw a coin, we collect the data. First step of the definition of the statistics is the collection of the data. So all possible results, all possible outcomes, if you throw a coin, are head or tail. Each outcome in a sample space is called an element, means H and T are the element or member of the sample space. So when a coin is tossed, possible sample space are H or T. When tossing a dice, sample space are maybe 1, 2, 3, 4, 5, 6 total possible outcomes. So in formula of the probability, we will use the definition of sample space. And next definition, event. One or more. In sample space you have all, but in this one or more of the possible outcomes of doing something. Doing something according to the conditions, or one of the possible outcome of an experiment. Same experiment, one of a possible outcome of a statistical experiment or experiment is called an event. We will also use this word event in probability. And what is the event? An event is a subset of a sample space. We select the event from the sample space. We find the probability always, probability of event, with the help of sample space, because the formula of the probability is number of outcomes of event divided by possible outcome, possible sample space, all results. So with the help of this example you can understand what is the event, what is the difference between the sample space and event. Event is the part, subset. Subset means part of the sample space. First example is when tossing a dice. Sample space are 1, 2, 3, 4, 5, 6. Same as the sample space 1, 2, 3, 4, 5, 6. Let suppose A is the event. For event we use the capital alphabets A, B, C, D, E, F and so on. Instead of long sentence, long condition, we use the alphabet. Let A is the event for even numbers occur. If you throw a dice once, A is the event for even number occur. From this sample space you can select the subset, because event is the subset. A is the 2, 4 and 6. Even numbers are in this 2, 4, 6. So A is the part or subset of the sample space. A is the event. This is the condition. Maybe odd number, maybe divisible by 2. Suppose B is another event. For odd numbers will be 1, 3, 5. Suppose C is another event. Divisible by 3 will be 3 and 6. Or divisible by 2 maybe 2, 4, 6 and so on. So you can draw more than one condition from a single space. You can calculate the probability of more than one event of a single sample space according to the conditions or event. Second example, if you throw a coin 2 times. If you throw a coin one time, outcome may be head or tail 2. 1, 2, 3, 4, 5, 6, there are 6 values. We use the values, not this result in text form or in actual natural form. We use the total number of outcomes value, because the probability, result of the probability is numerical value, lies between 0 and 1. I will explain in probability. So even numbers are this. Second example, if you throw a coin 2 times or 2 coins 1 time, the result will be same. 2 coins 2 times means 2 power 2 will be 4. 1 coin 2 times means 2 power 2 will be 4. So if you throw a coin 2 times or 2 coins 1 times, the result will be same. So in one coin maybe head, second coin tail, maybe in first coin head, second coin tail, maybe in first coin head, second tail, both may be tail. So event define, this is given, condition will be given. A is the event, exactly 2 heads appear. Suppose you want to calculate the probability of exactly 2 heads appear if you throw a coin 2 times. So first we will draw the possible outcome and then outcome of the event. Then we will apply the formula of the probability. Number of outcomes of the event divided by the possible outcomes. So A is the event, exactly 2 heads appear. 2 heads appear, there is only one outcome, HH, right, in this set A. A is the 2 heads appear. And what is the B is the another event, at most 1 head appear. At most 1 head appear means minimum, maximum 1. Maximum 1, not more than 1. ज़्यादा से ज़्यादा. Okay, ज़्यादा से ज़्यादा. At most ज़्यादा से ज़्यादा, at least minimum, कम से कम. So at most means maximum 1 head appear. So maximum one head appear means HT, TH and TT. Maximum one may be less than one but not more than one. Minimum one may be 0. Here 0 head appears, 0 is less than 1. So maximum one head means maybe HT, TH and TT 0, not more than 1. Maximum 1, not more than 1. So there are 3 outcomes. Suppose if you want to calculate the probability of at most one head appear if you throw a coin 2 times. So probability will be equal to 3 upon 4. There are 3 and this will be 4. Okay, we will use this example also in probability. And after this, I will explain some conditions or characteristics of the event. But in probability, we will use the sample space and event with some assumptions. So what are the assumptions and condition characteristic of the event? Event may be mutually exclusive events. What is the mutually exclusive? If they cannot occur together, they have no element in common, that is A intersection B null set. In example number 2, previous example of the event, this example, you know that there is no intersection. So you can say A and B are mutually exclusive event. And the probability of mutually exclusive will be equal to 0. There is no set, no member, no element. So when 2 coins are tossed, sample space are 4, same as previous example. This is example number 2. A is the event exactly 2 head, B is the event at most 1 head appear, A, B null set. Intersection of A, B is the null set. So probability of null set is equal to 0. And probability of sample space always equal to 1, and probability minimum may be 0, maximum 1. 100% chance or 0% chance. And these events occur equally likely and independent event. Equally likely means equal chance of occurrence. Suppose if you throw 2 coins, both have equal chance of occurrence, maybe head and maybe tail, 50-50% chances. So if they have the same chance of occurrence, experiment is continue a very large number of time. The events occur with equal frequencies. Equal frequencies mean approximately equal, because with the help of frequency you can calculate the relative frequency, and relative frequency is also called the probability. So if they have the same chance of occurrence, for example, if you throw a coin, both have equal chance, 50-50%. In this equal chances of occurrence, 1 upon 6, 1 upon 6, 1 upon 6, total will be equal to 1 if you add all 1 upon 6 times. 1 upon 2 plus 1 upon 2 will be equal to 1. So for example, a coin is tossed, it is just as likely to occur head as to occur tail. Equal chance of occurrence. If you throw a coin, maybe head occur, maybe tail occur. You cannot say if head, first head will be occur and second time tail. No. Equal chance. Maybe first head, maybe first tail. Independent event. If the occurrence of one event does not affect the occurrence or non-occurrence of the other. For example, tossing 2 coins or tossing a coin with a dice. Suppose if you throw a coin 2 times or 2 coins 1 time, if first time head appear, second time maybe head, maybe tail. Okay, both are independent. Suppose if you throw a coin 10, you want to throw a coin 10 times, 9 times head appear, in next time 10 times maybe head, maybe tail. Both are independent. You cannot say 10 times will be also head. No. If the occurrence of one event does not affect the occurrence or non-occurrence of the other. For example, tossing two coins. If you throw first time head appears, second time maybe head. First time if head, second is also independent, maybe tail. This is the maybe, this or this or this. First time maybe tail, second time head. First time maybe tail, second time also maybe tail. So both are independent. Same as if you're tossing a coin with a dice. Suppose if you throw a coin, in coin head appear. In dice maybe 1, 2, 3, 4, 5, 6 if you throw a coin with a dice. If tail appear, with tail maybe 1, 2, 3, 4, 5, 6 anyone. All are independent. Okay. Now after this we will solve an example. How we draw possible outcomes and some conditions of these sets, union, intersection, complement, etc. So this is an example or numerical. 3 coins are tossed. Before this you have used 1 coin and 2 coins. 1 coin maybe H2, HT, 2 outcomes. There are 2 sides of the coin, 2 power 1 times means power. If throw a coin 2 times or 2 coins 1 time, 4 outcomes, 2 power 2, 4 outcomes. Same as 3 coins are tossed, outcome will be 8, 2 power 3, 8. A denote the event exactly 2 heads. Another event B denote the event at least 2 heads. C denote the event less than 3 heads. D denote the event at most 1 head appear. List the elements. Draw all member of the sets of the A, B, C, D and S of the sample space and belonging to the event A, B, C, D, and then find A union B, B intersection C, A minus B, B minus A, D complement. So first we will draw the all possible outcomes. 3 coins are tossed, in all 3 may be head, or with 2 heads, in first, second head may be tail in third. Change the position of tail in first head, second tail, third head. Now change this position of tail at this first position, tail, head, head. So there are 3 outcomes with 2 head and 1 tail. Now maybe 1 head, 2 tails. Change the position of the head. There are 3 also, 1 with 1 head, 2 tail. And there is no head, 0 tail. In this 0 head, in this 0 tail. In these 3, 1 head, 2 tail. In these 3, 2 head, 1 tail. All possible outcomes are 8. Okay. According to the condition, event is the part or subset of the sample space. So according to the condition, exactly 2 heads appear. Exactly 2 heads means these 3. In this 2 head, in this 2, in this 2. In these 3, 1 head, 0 head here. Here 3 head. So there are 3. There are 3 members of the set with this condition. Exactly 2 heads appear. So suppose you want to calculate the probability of exactly 2 heads appear if you throw a coin 3 times or 3 coins 1 time. So probability will be equal to 3 upon 8. Out of 8, 3. Very simple. So first we write in numerator number of outcomes of event and divide by the possible outcomes. Same as B. This is for your homework. Denote the event at least 2 heads appear. At least 2 head, minimum 2. Not less than 2, but maybe more than 2. So at least 2 means these 2 and these 3 head. Minimum 2, maybe more than 2. So there are, we will select 4 members. Value will be equal to 4. C denote the event less than 3 heads. Less than 3 head means in this 3, less than 3 means these all 7. D denote the even, at most one hat, maximum one, not more than one. So from these last four will be included in this. And then find the union. Union means the member of this set A and the member of this set B. If any member occur two times, we write only one time. Intersection means the common of both B and C. If any member is common, we will write here A minus B means subtract from A the member of the B. From A, subtract the member of B. If there is no same member, suppose, so we will write A as it is. If all the members are same, both are same, the result will be equal to null set. And A minus B is not equal to B minus A. In this, we will subtract B from A. In this, subtract A from B. D complement means subtract from S complement. In mathematics, we use the universal set. Complement means subtract from U minus A complement. The same way D complement will be subtract from the member of the D from S. Okay. Next time we will start probability. Memorize these definition and concept of the definition. Sample space, event. We will use these terms: mutually exclusive, equally likely, independent event with conditions. Okay. Allah Hafiz.